Core 2, Paper 3, question number 6. Now certainly cut down on the exam paper, so let's look at that. The line with the equation y equals 2x plus 12 cuts the curve with the equation y equals x squared plus 5x plus 8 at P and Q. I've just shown it on the diagram, so I've called that writing and just put it all on the diagram. Find the coordinates of P and Q. In other words, find when the x and y values are the same in both of these equations. Where they cross, these two equations are equal. So it's a form of solving simultaneous equations. Where they cross, they are equal. So in other words, if y equals that and y equals that, then that quadratic will equal that linear. So that's our first line. We'll subtract 2x from both sides. We'll subtract 12 from both sides. 8 minus 12 is minus 4. Now let's go for a bit of factorising. Is that 2 times 2, or is that 4 times 1, or is that 1 times 4? Get the signs right. I need a plus and a minus. That needs to be plus, so the plus needs to go there, the minus goes there. Straight away this time I'm going to write down x equals plus 1 and x equals minus 4, being confident that that is so. Now this is x coordinate of P or Q. This is an x coordinate of P or Q, but just looking at the logic of it, that one must be the minus, so that's P, and this must be the plus, so that must be Q. What haven't I got? I haven't got the y coordinate. To get the y coordinate, you can substitute the x coordinate into either of those. Obviously you might as well substitute into the easier one. So x is 1, y is 2 1s, a 2 plus 12, that's 14. X is minus 4, y is 2 minus 4s, which is minus 8, plus 4 is plus 4, 8, minus 8 plus 4. Lastly, find the coordinates. So I think the examiner is going to expect you to write these coordinates down. I don't think he's been too impressed if you just left it like that. You are expected to write the answers down. Marks. A mark for getting that quadratic. A mark for getting these two answers. A mark for each of them, I should say, for the x values. And then a mark for the two coordinates completed. So let's question number 6, part A. Question 6, part B. I've repeated the diagram and I've written the answers to part A up there. I've put those two coordinates on there. Find the area between the curve and the line. Find the area between the curve and the line, that's the bit that's shaded. So what we need to consider is, if we look at this shape from there to there to there to there, that shape is a trapezium. So if I find the area of that trapezium and I find the area under the graph, I should really say between the curve and the x-axis. If I find the area between the curve and the x-axis, subtract from the area of the trapezium, I'll have the area I'm asked to work out. Let's write down a sentence so the examiner can follow my train of thought. Shaded area equals area trapezium minus area under curve. The examiner will be more than happy with that. I mean, if you really want to show off, you could letter that and give the shape a P. You could put an A there and a B there and say the trapezium P, A, B, Q, but that's fine. So equals, the area of a trapezium is half the sum of the parallel sides, so we need to look at what that goes up to. That goes up to 4, doesn't it? And that is at 14. Just spotted something. Right, the trapezium is not that, but from there to there to there to there. I've not written anything down wrong, but I just actually focus on the wrong trapezium. That was a bit bad, wasn't it? Right, half the sum of the parallel sides, that is 4. And that's what made me think of it, that is 14. Multiplied by the distance between them, from -4 up to 1 is 5. So that's the area of trapezium, half the sum of the parallel sides multiplied by the distance between them. That's 4, that's 14 from there. Minus the area under the graph. To find the area under the graph, we need to integrate between the lower limit of -4, the upper limit of +4, the equation of the curve. With respect to x. Do a bit of working out. That's 18. Half of 18 is 9, 5 9 is 45. Could have done that with a calculator, yes, but there you go. Now let's look at this bit. If we integrate this, I've got to raise that by 1 power and divide by that new power. Raise that little 1 up to a 2 and divide by 2, and if we integrate that number, we'll get x back. Upper limit, lower limit. As I've said before, at what point you pick up the calculator is up to you. But I'm going to show this like this. Put the 1 into there, that's the upper limit. That's the upper limit. So you've got 1 cubed over 3. 1 squared multiplied by 5. And 8 ones. Now normally it's this bracket minus this bracket. But this minus in front is going to change that to a minus and this to a plus. So let's put the -4. 4 cubed is 64, so it's going to be -64. -4 all squared is +16. 5 16s is 80, divided by 2 is 40. 8x is 8 minus 4, which is -32. Now I pick up the calculator and I use the fraction button because of the third. Then I get a nice fraction answer rather than a messy decimal. Now if you do that, it actually comes to 10 and 5/6. If you do that, it comes to -13 and a third. Then if you do that, you get the answer. Now that's a spot-on, perfect, exact answer rather than a decimal. But I don't think that'll make any difference. But this is nicer, neater. I reckon all of this lot. If something goes wrong, I'll get some marks for along the way. I think you get a mark for making that statement, so you know what's going on. And then a mark for the area of the trapezium, and a mark for the integration. Then if you showed these answers, if that went wrong, then I would suggest you get a mark for the ones that you got right. If you don't show this and you get this right, you'll get all 4 of those marks. But I hope I'm making my point about showing the working out. If it goes wrong, you'll get something. That's question number 6. If you want to see the rest of this exam paper worked out, not just question 6 that I've just done, but all of the rest of it, go to www.mathstutor.biz, where you'll get the opportunity of buying a set of DVDs on Core 2. This is Set 1, Paper 3. So you'll get this particular paper, a copy of your own. You'll get a DVD for Set 1, Set 2 and Set 3. So in there, on that CD or DVD, will be all of the rest of the questions as well as this particular one. So visit www.mathstutor.biz and I'll be glad to hear from you. If you don't, I still wish you good luck in your exam.